chosen location to carry out our project was at T Junction at FSPU UiTM Shah Alam.
First noticeable issue is the lack of safety barriers along the sidewalk, which is risky on busy roads. Without a barrier, even a small misstep can be dangerous. For example, two friends jogging around without paying attention to their surroundings could cause one of them to lose balance and fall onto the road. As we observe here, one of the major safety concerns is the absence of zebra crossing. Without clearly marked pedestrian lanes, people are forced to cross the road at unsafe, random points, then increasing the risk of accident, especially with fast-moving vehicles. The next issue is the bus stop directly on the roadside due to the lack of proper bus bay, blocking one lane and disrupt the movement of other vehicles. Passengers also face safety risks when getting on or off the bus, especially with cars passing so closely. Another problem we notice is speeding. Many drivers rush through this area to get their destination quickly without slowing down even near pedestrian activity or bus stop. This behavior not only breaks speed limit but also put vulnerable road users at risk. At night, one of the problems we observe is the flashback effect from the road signage. When vehicle headlight hit the sign, the reflection becomes too bright and unreadable. This makes it hard for driver to see important information, especially at high speed. Another problem is poor lighting near the pedestrian crossing. As shown here, there's no street lamp installed close to the zebra crossing, making it very hard for both driver and pedestrian to see each other at night.
Traffic counter to manually count and classify vehicles. Radar speed gun measure the speed of moving vehicles.
Next, I will present the data analysis of our traffic junction audit project. We collected data on traffic volume, spot speeds, and pedestrian counts to understand how traffic behavior changes depending on the time of the day. In volume study, for traffic composition, we observed that most vehicles were cars and motorcycles. Motorcycles had a slightly higher proportion in the evening, while cars were more common at night. To better understand the impact on road capacity, we analyzed volumes in PCU unit. In the evening, the total PCU was 665.25, while at night the PCU dropped to 456.25. The PCU difference is significant because fewer heavy vehicles and buses were operating. This means evening traffic creates higher congestion pressure. When we analyze the total vehicle count by time and direction, we observe that in the evening, direction 3 contributed the highest volume, especially between 5:50 to 5:55 p.m. with 31 vehicles. In contrast, during the night session, direction 4 maintained consistently high flows, peaking at 28 vehicles. This indicates that direction 3 likely serves a commuting corridor, while direction 4 carries more balanced traffic even in off-peak hours. We also identify peak periods. During the evening, traffic peaked between 5:50 and 5:55 p.m. with 83 vehicles in 5 minutes. Night traffic remains steadier with the highest interval reaching 56 vehicles. For spot speed study, the histogram shows how many vehicles were in each speed range. In the evening, most vehicles travel between 25 and 34 meters per second, with the highest count in the 25 to 29 meter per second range. At night, the pattern shifted slightly higher with more vehicles in the 30 to 39 meter per second range. The frequency distribution graph shows the same trend more clearly. Speeds peak around 27 meter per second in the evening and increase at night as traffic volumes decrease. Overall, the mean speed rose from 27.88 to 31.5 meter per second, and the 85th percentile increased from 34 to 36 meter per second, confirming that vehicles tended to travel faster and more consistently at night. For pedestrian counts, we observed that it were higher in the evening session with 40 crossings, compared to only 15 during night hours. The busiest period was between 5:15 and 5:20 p.m. with 8 pedestrians crossing. The drop in pedestrian volume at night likely relates to reduced foot traffic and less commercial activity.
We proposed the establishment of a pedestrian crossing to facilitate safe pedestrian movement across the road, particularly given the high foot traffic in the area. Secondly, we propose the installation of chevron alignment signs to clearly delineate the sharp curve and provide drivers with advanced warning and directional guidance. We also propose the installation of speed hump with pre-warning rumble strip. The strip will provide an early warning to drivers, prompting them to slow down before engaging with the speed hump. Next, we propose the construction of a bus bay at the bus stop. It will allow buses to pull over completely from the main traffic flow, enabling passengers to board and align safely without obstructing through traffic. We also propose the installation of pedestrian guardrails along the entire length of the walkway adjacent to the main road to enhance pedestrian safety and prevent unauthorized access to the roadway. We propose the replacement of current signage with new signs featuring high-performance retroreflective shaping to significantly enhance visibility and driver response. We recommend installing brighter street light to achieve suitable illumination on the road and pedestrian walkways to improve the visibility of pedestrians for drivers.